We're getting like 6,000 to 10,000 bundles a second into our system. We have to simulate all those, and that's been pretty tricky. 2 weeks ago, we had 2,000 pending bundles, and now we're at like 20,000. Now it's like, oh shit. Now it's like, make sure stuff's correct, and then kind of do this dance where you increase the capacity a little bit, see what breaks, fixes it, increase capacity, and just finding a lot of bottlenecks in the system.
Scraping Bits is brought to you by the following sponsors. MEV Protocol. Maximize your ETH staking value with MEV ETH, exclusively on MEV.io. And Composable. Execute any intent on any chain, coming soon to mantis.app. That's mantis.app. And Fastlane Labs, the only MEV and intent-centric team that has a daily deodorant application rate of over 68%.
GM everyone, my name is Tagachi, the host of Scraping Bits, and today I'm with Lucas Bruder from Jito. How's it going?
Hey, pretty good. Can't complain.
Can't complain.
Thanks for having me on.
No problem, thanks for coming on. Just for the people that aren't familiar with you, who are you and what do you do?
Yeah, I'm the co-founder and CEO of Jito Labs. Jito builds MEV infrastructure on Solana. So built a MEV validator client for Solana. That's a fork of the Solana Labs or Onza client, and built a kind of block builder equivalent on Solana.
Yes, you kind of taken it by storm, Solana. But just before we get into all of the weeds of Jito and Solana, MEV and all whatnot, how did you get into this? What you want to Ethereum before doing MEV? Tell me the lore behind yourself.
Yeah, so I think my first crypto experience was back in 2017, kind of towards the end of the cycle. In like November, and bought like Litecoin, Bitcoin, Ethereum, and kind of just from like an investment angle, like getting into it. And then I guess before that, like studied computer engineering in school, did firmware engineering, so like low level C, bare metal, RTOS type stuff, kind of like a nerd, basically a nerd. And then got into crypto from like the investment standpoint, and then started kind of learning about all the technology, and over 2019, 2020, got a little more involved in it from like a learning standpoint and crypto Twitter and all that. And then I think late 2020, discovered the Keeper DAO and Rook and their like hiding game, and started hanging out in the Discord, met a lot of people that are still kind of around today, like Snoopy and stuff like that.
Yes, Snoopy. I remember him.
Yeah. So yeah, discovered that, and then kind of started going down the MEV rabbit hole. Read the Dark Force article from Dan Robinson at Paradigm.
Oh, yes.
Talking about like the generalized front runners and stuff like that. And
did you ever make one?
No.
Come on.
Yeah, kind of got introduced to that. And then I guess I did work on some MEV stuff on Ethereum, just like arbitrage and stuff like that. But it's kind of like right as Flashbots is taking off and trying to like keep your, like work on the bot from the ground up, keep your edge, and like also kind of do this like split between Flashbots and the just like low latency arbitrage and PGA type stuff, and a full-time job. It was just too much. So I kind of put that on the back burner for a bit, but definitely learned a lot about kind of how to set up these nodes and how to tune them and how to do simulations, and like thing is like open Ethereum or parity, and then fell down the Solana rabbit hole.
What made you get into Solana? Because I was always interested in it, but I thought it would die, and I never like fully invested. And now I'm coming back, and I'm like, we have to do this round 2. So what made you take that leap?
Yeah, I think it was a few things. One was, funny enough, it was SBF's $3 tweet. Like, I'll buy all the Sol you have at $3. That was like, I think it was like that, or maybe there's something else, but I think there's that. And then the more I started reading into it, I was like, I'm a firmware engineer, did robotics, like low level computer system type stuff where you're like talking directly to registers and reading and writing to like IO through registers, and just reading through the Solana documentation and like code base is like, oh yeah, this is like pretty low level. Everyone's kind of writing it off that it like won't work and it's not the way to do it. But I feel like there's a lot of efficiency that you can kind of gain by taking this route. So I guess also similar to you, like I I guess I did one of the first hackathons. And before we started the podcast, you're like, oh yeah, I like Solana because it's like really hard and it's like really challenging. And at the time in like 2021, there was like no documentation and it was just like really hard to figure out. And if you're an engineer that loves engineering, then when stuff is challenging, you tend to want to learn more about it. So that's kind of how I got into it.
Yeah, when I think about it as well, it's like, oh, if I'm finding this hard, everyone else would probably find this hard. And if everyone else is finding it hard, they'll probably not do it. And so I'm the only one doing it at the end of the day if I keep going through with it. So it's like bullish that it's hard.
Yeah, there's like the chewing glass meme. There's just a lot of the chewing glass stuff on Twitter. It's like, yeah, I like that.
When I was going through that Anchor Discord and I was asking some questions, he was like, you're finally chewing on glass.
Yeah, hopefully it's starting to outgrow that phase a little bit. But at the time, and still a little bit, there's definitely a lot of chewing glass.
Oh, definitely. Since Jito was based off like the Solana validator, right? How did you get to the point of actually building the POC? Was there any specific components of the validator you're looking at the most over others? What were the most important parts for you to identify and look into to modify?
Yeah. So yeah, I guess we started, my co-founder I met in like, I think it was like May or June. And I guess the original idea was basically like a backrun service. We were like, oh yeah, like we could backrun people and give them money back based on, you know, if there's any arbitrage or if they're leaving any scraps on the table. And we like started looking into, it's like, okay, now we have to like do the proof of concept or look to see how it's done. And we started reading through the code base. How do transactions, how are they formed on Solana? How do they get from the user, like through the wallet to like the leader, basically? How does the leader schedule work? Once the leader receives it, what's it do with it? How does it basically get processed and propagated out? And basically realized that it would have been like super hard or impossible to backrun people just because of the way the scheduler is built.
Why would that be so hard to backrun people with the scheduler?
So Solana block production is stream based as opposed to emitting the entire thing at the end. So on Ethereum, you basically emit your entire block every like 12 seconds or so, and the rest of the network receives it and processes it. On Solana, you are like, when you're a leader and you're producing a block, you are basically looking at the transactions that you have. You're starting to process them as soon as the slot starts, and you're processing them and then basically, you know, executing the transaction, saving the state, propagating it out to the rest of the network. In the rest of the network, live mid slot is actually replaying that slot live. And so if you wanted to backrun people, you'd kind of have to like squeeze it into that stream. And then also the current scheduler, it's a little different from what is back in the day, but basically the same idea. And it's essentially random. So like we could try to backrun people like...
Oh, it's random.
Kind of, yeah. I mean, there's like priority fees, but it's kind of a meme at this point.
Why is that?
There's 4 threads that do execution in the validator client.
Is that the scheduler?
Yeah. I guess it's like the scheduler / executor. There's 4 threads that execute non-vote transactions. It's like user transactions. And basically every thread has its own like thread local storage of what transactions are pending. And so you can have one thread with a bunch of like high priority stuff and another thread with a bunch of low priority stuff. And like the threads are kind of just like all thrashing on each other.
Right.
To try to process as much as they can. And there's no validator global view of what's pending. And so, yeah, that'll be fixed in 118. But
yeah, the new scheduler architecture. How are you going to implement that? Is it just like a PR or how's that going to work? What's the difference from like 117 to 118 for the people that aren't familiar?
So yeah, 1E, I would say the thing that I imagine there's a bunch of performance improvements I'm not super familiar with. I think the thing that you see the most of on Twitter is the new scheduler. And, you know, I kind of walked through what the current scheduler is, where it's basically, there's 4 threads. They basically just like churn through all the packets from beginning to end. Each thread local packet queue is sorted by priority. So there's like some priority within a single thread, but you also have other threads that are competing with you that, you know, they're just thrashing. 118, there's a new scheduler. I can't remember what they're calling it. Basically, they add another thread, which is the scheduler thread. And basically, it's basically collecting all the packets in a single thread. And then it's building basically a graph, like a tree of all the it's sorted from high priority to low priority. And then you have all the dependencies in there as well. So you're like, oh, this like at the top of my queue, I basically have no dependencies. The further you go down, it's like, okay, I need this transaction to execute before this one, and so on. And as you're going from the top to the bottom, you basically you'll build batches of work, and then you'll batch the work out to the 4 threads that I guess we think of today. You just have like a centralized planner, and then there's like a planning thread, and then it dispatches work to a bunch of other threads that process it, and then it gets notified when it's done, and it will unblock stuff and rerun it. So yeah, I think it'll be pretty promising. I've looked at some of the blocks that it produced on mainnet back in January. There's like a super small amount of stake running on it just to test it out. It looks pretty good.
What do you think are like the main kind of optimizations the current Solana validator needs to get to like the next level? A big proponent right now is obviously spam. And I've seen blocks with 2,000 transactions. I can't imagine the amount of block transactions being sent to the validator. If there's 2,000 transactions in a block, it must be like tens of thousands.
Yeah, they're getting like 50,000 a second to 100,000.
Yeah. I guess it's like, does that even become a hardware problem, a software problem at that point? Or is it really a hardware problem? Since if you're trying to simulate all this stuff, there must be something you got to do to work around, 50,000 transactions. How are you meant to see which ones are actually worth including or not?
Yeah. So yeah, I guess some of the simulation stuff we do in a second, but as far as optimizations go, there's one big one right now that people are struggling with is Quick. And basically, there's some inefficiencies in the protocol, but I think the implementation as well and the library that's being used is not super performance optimized. It's not really made for like an adversarial environment. So the Onza team and Jito and Firedancer and a bunch of other margin team, a bunch of others are trying to figure out like what are some low risk, high reward things that can be put into the network ASAP. A longer term, like maybe write a custom protocol that can run way faster and more efficiently.
So it's like sending the data across. Is that what Quick does?
Yeah, you can think of it as a mixture like UDP and TCP. Quick has like connections, so you can establish connections. All of it's over UDP, so you can establish connections with like some handshake. And then there's you can like throttle and rate limit people and cut them off. And there's similar to TCP, but there's no head of line blocking like TCP, so you can kind of get packets out of order. There's like retries and stuff like that.
So this is one of the big sections for optimization, apart from obviously the scheduler and the block engine.
Yeah. So there's like that stuff. There's basically saying now that if you optimize Quick, there's going to be other bottlenecks in the system.
Right. Yep.
And there's a lot of thread pools in the validator. So you just have like threads like taking up a massive amount of compute. So I think there's just like your compute isn't infinite when you're running these systems, and you need to try to like allocate. When you look at each system individually, you want it to run as fast as possible. But then when the whole validator is running, you might have like, if you're getting a bunch of packets, you're going to be spending a bunch of CPU time running signature verification on them.
Right.
But that might actually slow down your actual execution. So thinking like, how do you allocate these? You only have finite resources. So like, how do you allocate them? And then like, how do we get rid of all the thread pools and like try to make it so that stuff is trying to use the caches and things like that. So you're kind of getting into more like systems engineering and like some of that like high frequency trading to optimizations.
With the current scheduler, the 4 threads, why is it 4 threads? Can't it just be pushed down to a single one and actually have a better algorithm to, I guess, sort everything? Or why is it specifically 4 or multi-threaded, actually?
I think it's mainly just a performance thing. And in theory, if you have more threads, you can compute more stuff. So like validators on Solana are running relative to Ethereum, like pretty beefy machines. Like most people are running like 32 core machines. And so we're running 64 core, and our CPUs are like, they're using like 10 or 20% or 25% of CPU. So in theory, like at some point we should be able to like bump up the number of execution threads, like 16 or something way higher. And that should give us the network more throughput.
Why not just do it now if you've already got the computer?
I think given the state of the network, it's a little risky.
Okay.
Yeah, I think it's like, number one, make sure things are correct in the protocol. It's like we're not having like consensus bugs and
Oh, yes, that makes sense.
account mismatches. And then it's like find the bottlenecks and like kind of walk this line between like finding bottlenecks and removing them or making them faster, and then like increasing the throughput of the network. And you kind of get into this like dance where you're like going back and forth.
Oh, yeah, definitely. When we're thinking about this throughput, the major thing is simulation. But you can have like these 50,000 pending transactions. If you're saying per second, that's a lot of fucking transactions. So how do you actually filter what is spam, what is useful? Are you doing like some kind of simulation optimization where you're not simulating the entire thing, removing some parts? What's really happening behind the scenes?
Yeah, so I guess everything I covered up till now is like the default scheduler. And then there's obviously Jito's block engine, which is similar-ish to a block builder. Our unit of work is bundles instead of the entire block. People can submit transactions and bundles to us. We simulate them, figure out which ones are paying the most, and then forward them to the validator. We have a custom right now it's just single-threaded execution stage that just goes through the bundles in FIFO. And so, yeah, we're getting like 6,000 to 10,000 bundles a second into our system. We have to like simulate all those, and that's been pretty tricky. 2 weeks ago, we had like 2,000 pending bundles, and now we're at like 20,000.
Oh, okay.
And so
only 10x.
Yeah. And then Friday, it was like 200,000. So yeah, now it's like, oh shit. Now we have to do the same dance I was talking about, where it's like, make sure stuff's correct, and then kind of do this dance where you like increase the capacity a little bit, see what breaks, fixes it, increase capacity, and like just finding a lot of bottlenecks in the system. But it's been pretty fun.
So when you're simulating, are you just like simulating everything, every single transaction, every single bundle? And if you're getting 20,000 bundles, let's say each of them have 5 transactions, then that's a fair amount. How are you doing that all in 1 second then?
Yeah, I don't want to give away like too much alpha, but I guess
you can give away a little bit, just a little bit.
Yeah. I would say we're simulating like most of the stuff that comes into our system, and then we basically have an auction. Right now we're running an auction every like 200 milliseconds. So basically we like take all the bundles, and we can actually, I guess you're kind of diving in, or you've been diving into Solana development. So like, you specify your accounts up front. You say like, oh, I want to read from XYZ and write to ABC. And we can basically build a bunch of disjoint sets from that. And so we like take all the bundles we have, build some of the disjoint sets based on like some filtering and other stuff that we do. And then we have a custom simulator that we built that we can just throw a bunch of stuff at it, and it will spit back results for what's the most profitable. And then we kind of take that and forward it to the validator. Okay.
If I was let's say a validator, if they're getting both standalone transactions but also bundles, how do you deal with that confliction right there? Let's say like one transaction or multiple transactions you're getting streamed from both ends, but then you have to sort them in a way where you're simulating the bundles and the standalone, and you have to order them where it's not conflicting. You have to remove a bundle or keep the bundle. It's a whole bunch of things happening at once instead of just like, I guess it's actually just Ethereum block building. At the end of the day, you still get transactions from public mempool, but also building.
Yeah, right now we're not building with transactions from like the Solana quote unquote mempool. It's just what people send to us directly. I think at some point we'll get there, but we want to get the system running well, and we've been seeing insane demand, so there's a lot of stuff to fix.
Let's say like a validator was receiving these bundles and standalone transactions. How do you think like these guys would even build their blocks then?
Yeah, I mean, it's basically what the algorithm that we encoded in the validator. So they just basically the mainnet's running 117. There's like 72% of Solana stake running the Jito Solana client.
Right.
And so they're getting transactions kind of the normal way and like processing those. And then we're running our auctions in parallel, submitting the bundles to the validator. And the validator has a special kind of stage or special execution stage where the bundles go. Those have some priority over the normal transactions. So that queue, you know, the normal queue might be like 10,000 transactions or something, where our queue, it's like very high signal, very well-paying transactions. I guess for context, like right now we're building anywhere from like 5 to 15% of the block, and validators are making more money than they are the other 85% of the block that pays priority fees. So there's like, we do a lot of simulation, like try to figure it out. So we kind of just forward it and give them pretty profitable blocks.
That makes sense. But they're still getting overran with these fucking spam transactions. I guess like I think a common thing now is they just blacklit like IPs, but that's not really a long-term solution. You could see tons of transactions from the same signer, maybe like revert transactions, like if not executed, revert. Like a big thing I wanted to do on Ethereum was just like reverse engineer transactions, like the core data, and then look at the bytecode. But obviously that's takes a lot longer than just like having some heuristics.
Yeah,
it's an interesting problem.
Right now they're kind of relying on stake to someone to be that signal. So like on Quick, there's basically, you can think of there being like 2,500 seats or 2,500 connections. 500 of them, or 500 connections are allowed from unstaked RPCs, and then 2,000 are allowed from staked validators. And the theory is that it's kind of like software quality service or stake weighted quality service. Like if you have more stake, you should get access to more bandwidth. I think it's like a reasonable approach, but I think in theory, obviously it can't handle like infinite packets, and so you need to figure out how to prioritize them. But like I feel like there's probably a better way to do it, where like maybe you are looking at a specific connection or a specific IP, and like how much of the priority fee are they paying a lot, and like are they sending you like good stuff for some definition of good, and then like if someone's just sending you a bunch of garbage, or like sending you stuff that like maybe they don't have enough in their balance to pay fees, or they're malformed or whatever, you just disconnect those people.
Yeah, I guess they just spam like insane amounts of transactions and there's no penalty. Or the penalty is very not strong enough to disincentivize spamming. Have you seen any specific techniques that people are doing when spamming?
Yeah, there's a pretty common technique right now. I don't want to say what it is because it's being used on mainnet right now, but
okay.
I guess in the past, like there's some other stuff like people, and this is like searcher PvP stuff, where you have like searchers can't write to and read from an account at the same time. And so you have searchers this is probably still going on in mainnet. You have searchers that will like write lock other searchers' accounts in their transactions to try to slow them down. And then you have some searchers have like 300 accounts that they rotate their funds through to try to like stop this from happening.
Yeah. So what does a write lock look like? So they just try and interact with the other bots, basically program.
Yeah.
And it locks it. The operator cannot actually use it.
Yeah. So like when Solana's multi-threaded, and the reason that's multi-threaded or that it works so well is because you declare all your state up front.
Okay.
And you say, I want to read, like, you know, let's say there's like a market at account A and I want to write to it. Or like, there's like my token account for USDC. I need to write lock that because I'm going to modify it and write to it. Like I'm going to take funds out of it and spend it or whatever. And so basically I have, you know, bots are constantly write locking their own token accounts because they're using them and like subtracting funds out of there and sending it to market or whatever. And then so you have other bots that are competing against them that will write certain bots that basically write lock those other bots' token accounts and like not do anything with it. They'll kind of just like spin or something.
Okay.
So then yeah, you have like searchers are like constantly rotating keys and like all this crazy stuff.
when they right lock it, is it for the entire block or just a single transaction?
No, just single transaction. But they'll also like send like the same transaction like 10 times or something,
Oh,
or 100.
okay. But then it's up to the validator to, I guess, identify this and then get rid of those
Yeah.
bots, right? Because if they do it enough times, then they could do those right locks and then add their own transaction in between all of them, so the guy can't actually, I guess, get the background. That's what I'm assuming would happen.
Yeah. Yeah, you could do that. I think ultimately, like, the validator should probably do this, but also there should just be like, I think Solana hasn't spent the most time thinking about economic incentives compared
Right.
to like Ethereum, where you have like all these crazy research groups and like
Yeah.
committees and whatnot that spend a lot of time thinking about this. And like, I would like to see more focus on like fees and economics to like
Yeah.
discourage this behavior. That's been kind of a hot topic in Solana recently, the fees.
Oh, yeah. Definitely. I remember when I was first looking at it like 2 years ago, the spam was still going on. I didn't really investigate it, but what other kind of war stories like this have you encountered during these years?
Oh man.
Oh no, PTSD.
Yeah. I mean, obviously, like all the halts are like pretty annoying
Yeah.
because you get like your pager duty goes off at like 2 a.m. and gotta like wake up and root cause it and fix it. There's been like some like validator. We pushed out a bug in like the early days of 1.16 that was causing like a few validators to crash. That's not ideal, but it was a pretty easy, stupid refactor.
What are your thoughts on like the sandwich validators? From what I've seen, is people actually insert their bots into the validator instead of just being like a bot by itself. Is this like the most common thing, even if they have barely any stake weight? Do people actually just run bots on the side without a validator, or how does this all work?
Kind of, yeah. I mean, there's a few different ways that you can do it. Like you can get access to the stream of transactions that are coming in and do it that way. I think there's probably some people that run them inside the validator, but like you really need to know what you're doing there.
And you need some stake weight as well.
Yeah, like you need stake. I don't know. I mean, I think there's probably Course One worked on this a little bit 2 years ago, where they built this like bot inside the validator client. It's definitely like interesting. I don't think it's like generic enough to where it will be as profitable as something more generalized. And I think that like if you're making a lot of money on ARB, then like you probably don't want to release your source code. So then it's just like tricky operationally to like, you got to get validators. You're not going to release your source code, but you want validators to run it.
Yeah.
But like they have like hot wallets on their validators that have funds. And so like you got to convince, if you want it to be like adopted, you have to convince validators that it's like trusted and you're not going to read through their file system. And then there's like, are there like performance impacts on the machine if you're doing this? And I think just the generalized, like we're seeing like a lot of like, I think earlier today we had our highest tips in 1 hour, like 1,500, and they weren't even ARBs. I think it was just like people like trading Tensor, doing something with the Tensor token launch. So it's like, those like super profitable opportunities. A generalized like arbitrage bot or whatever bot won't be good enough.
What does an MEV bot on Solana look like right now? I guess, let's say people are migrating from Ethereum to Solana because it starts to pop off in the bull run. How do you anticipate them actually building, well, what's common right now for a Solana MEV guy? I heard there's so much money on the table if you're good. So what does it take to be good? And what do these bot architectures really look like? Are they very similar to Ethereum or completely different? I mean, if we're talking about locking someone else's contract, I think that's quite a big difference. So what does it really look like?
Yeah, I would say it's pretty similar to Ethereum in like the building blocks, but the implementation is definitely way different. So yeah, I mean, you're compared to Ethereum, I guess it's kind of changing with timing games and stuff like that. Compared to Ethereum, the latency is much more important. So people typically run distributed setups in like Tokyo, Frankfurt, New York, West Coast, or whatever.
Right. Just co-locating.
Yeah. So you're kind of like finding regions of high stake, co-locating there. There's a lot of people, you're either running like a staked machine or you're we have a product called ShredStream, which basically gives you low latency shreds, which is the state that validators are propagating out when they're processing the slot. So because basically like the validator is processing the transactions and emitting the block, and you can respond and land a trade in the same block as another trade. And so you're like co-located, you're getting access to shreds fast. You're running something called Geyser, which is basically it's like a plugin model for the Solana validator, where you can get account state streamed out to you. It's basically sitting in between. The Geyser sits right before the accounts database in this validator client. So as soon as state changes and like is about to be written to, it'll send it out over Geyser. So you can basically, people will write like gRPC servers or something, send those out. And then, you're like churning through a bunch of data. The states change. Like if you're like trying to trade on a radium market, it's like changing like 100 or 200 or 300 times a second. So you got to make sure your pipelines are fast.
Reading from state, I was looking at Radium before and like trying to figure out the whole program stuff. And reading from state, you don't actually need like a function to get or view state, just like Ethereum. If you make a variable public, it makes an external function where you can just view it and it doesn't cost you gas. I guess like the only way you do that on Solana is just by actually getting the account address and then just like calling what data is on there. You can just do that with an RPC, making a function to get it, I guess. So,
yeah. Like no one actually, there's like a few cases where you have like getter functions or like getter instructions in Solana.
If it does like a application or something.
But for the most part, like I guess on Ethereum, I'm guessing if you want to read something, I guess the storage model of Ethereum isn't super clear to me, but like if you want to read something from a contract, you have to like spin up a VM and like call into this like VM, however that works, and like it'll like parse the storage or whatever and get you back the thing. But on Solana, everything's stored in accounts, and it's basically, you can think of an account like a C allocated like buffer of bytes. You can store whatever you want in there. So in Solana, you can get that by calling like get account info, or if you're running Geyser, it'll just be streamed to you. The most annoying part is that on Ethereum, like you can just call a function and it'll like parse it for you. On Solana, everyone uses a different way of serializing accounts, and there's no kind of like standard. Like I think people use like Borscht, people use bin code.
Oh, so you need like a generalized, I guess, decoder then, that's able to reverse engineer what kind of standard they use. But the only way you could do that is from checking the bytecode, right?
Yeah, you basically have to, like every library, and I guess this is why obviously the composability on Solana is nice, but for devs it's like pure hell. You have to read the account and like figure out what the source, like where's the source code for Radium,
right.
Where's the source code for like Orca, what accounts do I need to read. Typically the like addresses are derived from other addresses, so you kind of have this like chain of derivations that you need to do. And then like once you read the account, you have to parse it and like load it, so it, there's like an 8-byte header and there's a pub key here and like a bounce here and all this stuff, and it's
a whole
like
tree.
Yeah,
with that kind of data structure, I wonder how like MEV search is actually, I guess, stream updates. Because on Ethereum, you can just watch the mempool, see a transaction that emits an event like a swap, and you're like, oh, okay, now I know this is a obvious identification that I can go do an arbitrage and do that, or a liquidation or something like this. On a Solana, there's not really events. It's just, there's message logs that aren't really useful at all. I guess you have the pre and post balances, but then you still have to, I guess, decode what pool was this from? And then it's like, oh, okay, then given, 20, 30 accounts that was provided, how do I find this? And how do I figure out how to interact with this and all this jazz? It seems a lot harder, not as simple as look at event, do thing.
Yeah. No, it's definitely harder. I think Geyser does account updates, but you can also get transactions. So you can do stuff through there where like a transaction is basically a list of instructions. And so you can like An instruction has like a program ID, accounts, and the instruction data. And basically every Solana program is like kind of a jump table. They like jump into different things. So you can like parse the Solana transactions from that. And then also, I would say most people probably just look at the Geyser account state. They don't even care like what the transaction was doing. It's like, if this market changed, I want to know about it. Or if this, basically give me an update. Like you can go to Geyser and be like, give me all the Orca, any account that's owned by the Orca program, I want to get an update for that. And then you're kind of just like chugging through that and reading it.
Yeah, because the way I see, if you get this account and the state changed, you have to see who's the owner of that, and that's like a whole nother API call in itself as well. So then you're doing 2 API calls, which is just like, if there's multiple, if we're saying 10,000 transactions, how fast will that be? It's going to be a not doable, especially if you do like 50,000. API calls are like, they take too long. Like, when people in Ethereum, they would integrate their bot into the node, or like a full archive node, so you can grab the state without doing an API call. But in this case, it seems like, I guess you just have to be the validator, like do or die. That's why there's so much spam, I guess. You can't actually, you can't even front run someone because there's no member. I guess you could somehow if you knew who was sending the transactions, but it's really just like a black box.
Yeah, we had one of the first products we had is a mempool, and we just disabled it recently. It basically let you see like transactions before they were going to get executed. So validators would like connect to these things called relayers, and relayers would share their pending transaction stream with searchers, and that let them like atomically arbitrage stuff. So like you could have a bundle with a bunch of like users trade and arbitrages, but then, unfortunate things started happening and decided to end that product.
Yeah. Was it all the sandwiching stuff?
Yeah, there was a lot of that. We tried to stop it in a few other ways, or, try to mitigate it or prevent it. It's kind of a cat and mouse game. Searchers are very smart. If they can find ways to like get around things or limitations, it's like the timing game stuff on Ethereum where like people are kind of like pushing things and finding out where they can make more money.
So what were they doing to get around it?
So we tried for a while to basically prevent people from submitting bundles that had sandwiches. And then we saw people were like using different signers on the front and back.
Oh, yes. Okay.
And then they were like transferring between multiple transactions to like, basically we would have had to like build a graph of like all the transfers in all the bundles. And then they were doing it across different bundles as well. And then they were like doing it without bundles as well. We tried to do that for a little bit and ultimately decided like, if we're going to do this, like we need to do it right, and we can't really do it right now. So
yeah. It seems like a problem that's really hard to solve. If they're doing, multiple signers and transferring to kind of obfuscate it, I guess they could do like transactions before their back runs and make it seem like it's a different thing. But in reality, it's just a sandwich. Yeah, I can see how this would get hard.
We were a little optimistic, but then I think we got a little too optimistic, and
it's just so many ways. You're going to have like a generalized, maybe fuzzer in some way. I don't know, but you don't want to fuzz that stuff. So I guess it's the same with the spammers as well. It's like, how do you fix that? How do you fix sandwiching? Or maybe you can't fix sandwiching, but you could fix spamming somehow. What would be your kind of, if you were to try and fix spamming now, what kind of direction would you lean towards? In like high level, we don't have to leak alpha in any way.
Yeah. I think like revisiting, a lot of people are spamming because the probability of landing a transaction when you spam is higher than if you just send it once. So like, that kind of gets back to some of the networking stuff that we were talking about in the scheduler. There's definitely a lot of like fee related things that can be changed and optimized. So like maybe there's not a dynamic base fees on Solana right now. There's not. People are kind of using priority fees as like a dynamic base fee in some sense. So like, rethinking that, there's like definitely a world where we start to build a little more of the block. Like right now we're doing like 5 to 10%. Maybe we bump that up to like 20 or 30 or, higher. I think there's a lot of things that you can do to fix it. There's a lot of like core things that need to be fixed.
Do you think bots are like teaming up with validators?
We've seen a little bit of that. I mean, our system is kind of like the main way to do that. And there's definitely a lot of people using that. There are some other people that are kind of doing that, and they don't really have that much stake, I think. Maybe like 1 to 3%.
1 to 3% of the network?
Yeah.
How do you actually test validators? Like on, like, well, I guess you could do testnet, right? But like, you're going to have to force some transactions and spamming and sandwiching, like what we were saying before. But it seems like just test and prod.
There's a testnet that's used. We tend to leverage that a little bit. But obviously there's CI and unit testing and all that stuff. That's pretty basic. But the trickiest problems are like the performance ones. So we run a few validators at Jito Labs. And so we can test stuff on our mainnet validators. And that's kind of like the best way for us to do it in like a real environment.
I also am wondering of like, on like Ethereum mainnet, you can fork the chain to do like mainnet testing. But it seems like on Solana, there's no like archive nodes for like entire history of every transaction, every state. I feel like someone was working on this before. I think the guys at FireDancer so they could actually backtest FireDancer, but there's no tools like this. So do you have any idea how you would even do this then if there's no, I guess, recollection of state?
There is recollection of state. It's just not easily consumable right now. It depends what you're testing. Like if you just want to replay... If you want to test like your performance and like stuff running on a live network, then, you know, you can just spin up a validator and test it. If you want to test like correctness, and like, I imagine this is what FireDancer is doing a lot of, is replaying blocks to not only test, but figure out what are common access patterns? How do we optimize for those? What are some like really weird edge case scenarios that we don't have? And for that, you can
just download a block when it's live, something.
Yeah, you can. There's a few different ways. So when validators start up, they load from a snapshot. Okay. And that's basically, this is all the account state at slot ABC. And from there, you can basically replay all the shreds. And so, or the entries, which are kind of like another version of shreds, basically. And so there's a few storages for Snap, and then there's a few storage places for the shreds and ledger data. So I imagine what FireDancer is doing is like, it's like, oh, we want to replay the slot range. Let's go download the snapshot and then replay the ledger data through our consensus.
Yeah, it feels like Solana right now is Ethereum before Flashbots. Just complete dark forest vibes, but even darker because there's no tooling as well. I feel like it's pre-Foundry. It's up to like, it's like Truffle when that was the main testing suite, and that was I really hated that. But that's what it feels like right now. So what do you think Solana needs right now? What do you see the future of like searching and Solana in general? Yeah, how do you see this all playing out?
I mean, I think we definitely have a lot more tools and like reliability and performance tuning that we need to do to be basically building more profitable in more full blocks. So there's definitely a lot of stuff we can do. I think like just general tooling around Solana. There's a lot of tribal like knowledge within teams. So I think writing more documentation, open sourcing code, stuff like that to make it easier for people to develop on Solana would be helpful.
When open source block engine?
Yeah, I don't know. We'll see. No immediate plans for that. Yeah, I think that, and then getting more contributors, and then of course like getting more DeFi protocols building on Solana.
Yeah, definitely. Be the number one factor is how many people actually get onboarded.
Yeah. Every Solana project is like dependent on activity and other DeFi protocols and all that popping up on the chain and composability. So
yeah,
definitely want to see more of that.
I feel like on-ramping onto Solana is quite difficult because the concepts from EVM is so different. And obviously it's in Rust as well, so you have to on-ramp onto like a pretty difficult language, engineering language, instead of like a really super easy language. It's like a stack-based VM as well, instead of like a register. So I guess for anyone trying to get into like validating or writing tools on Solana? Do you have any like suggestions, recommendations?
Yeah, I guess to your last point, like I think yes, SVM's register based, but the cool thing about Solana is that like compute's basically free. So like most people, I know like there's like UL and assembly and all this stuff that people use in EVM, and like I don't know anyone who's done that in their Solana programs. You don't have to do like gas golfing or anything.
I feel like it's fun though. It's not just about the gas golfing. Obviously, that's a like big benefit on Ethereum, but I don't know. I think it's also really fun because you can do like obfuscation techniques that you would normally do in Web 2, but like now in a blockchain because it's based on CBPF. So I don't know. I feel like it's quite interesting, but obviously incredibly difficult relative to a EVM opcodes and whatnot. And there's no tooling. Like EVM.codes was a major factor in everyone learning it. But yeah, even I guess testing it would be really painful as well.
Yeah. I mean, you can, if you want to develop on Solana, then I would start with Anchor. And I guess like first understand like how the runtime kind of works. And then how does the instruction handler get called? And then start building on Anchor.
Yeah, I think a lot of people in EVM just looked at the execution layer and that saw how the opcodes were played out. And that's how you would learn. I think you could do the same on Solana, except it looks a bit harder because there's so much shit in the repo. Have you ever looked at the execution layer on Solana?
Like what part of the execution there?
I guess going through the opcodes, like what happens.
Not that low level, but I've gone through like all of the well, not all of it, but a lot of the execution code, like how here's a transaction, what happens when you execute it. Like, okay, you like load the accounts and you subtract the fee and you load your programs and there's the JIT stuff and then you kind of loop through all your instructions. And I haven't gone into like the SVM assembly stuff.
Yeah, I was looking at that stuff as well today, actually, what you just mentioned. I think like the hardest thing would be testing the validator, right?
Yeah, I mean, there's a lot of CI tests. Like CI takes like 2 hours to run.
Oh, God.
So there's definitely a lot of testing there. That doesn't catch everything. So there's a lot of testing that goes on DevNet and testnet.
I wonder how many exploits are happening and nobody's seeing them on Solana.
Hopefully not that many.
Yeah, maybe there's not too many. Oh, maybe it's all like the MEV bots, actually. That might be getting exploited, but you never know.
Yeah, I mean, I think if there's like bugs in execution, then there's going to be a consensus failure and like the network's going to halt.
Yeah, hopefully no more halting from today.
Yeah.
Interesting. Well, I'm keen to see how Solana develops, especially in this next bull market. I think it's going to be a major hot topic, just like it was, I think, last bull market. I remember it popped off one time, and the token just rocketed to like the new prices. What is it now? Like 200-ish?
Yeah, something around there.
Crazy. I remember it at like $2. But man, thank you so much, Lucas, for jumping on, taking the time, explaining Solana to all the EVM guys. Hopefully they all jump ship and join the new modern world.
Yeah.
And not sandwich, of course.
Yeah.
But I'm sure we'll definitely talk in the future as well. The next updates on Solana as well. So once again, thank you so much for jumping on, and I'll talk to you soon.
Yeah, thanks for having me.
Of course. Take care, everyone.